Hello, everyone. Hypothesis testing with z-scores, part 3. All right, so number 3. 64, n equal to 64 smokers were questioned about the number of hours they sleep each day. We want to test the hypothesis that smokers need less sleep than the general public, which needs an average of mu, or population mean, mu equal to 7.7 hours of sleep, with a population standard deviation of sigma equal to 0.5. If the sample mean is m equal to 7.5, do smokers need less sleep than the general public? So I circled plus because that's what we're looking for. Conduct the appropriate hypothesis test using alpha equal to 0.05 and state your conclusion in terms of this problem. Make sure to use APA style conclusions. All right, so step 1, state the hypotheses. Step 1. All right. So again, in symbols and in words, right? So our null hypothesis is that, and remember, we're hypothesizing that smokers need less, right? So that our alternative hypothesis, H1, is that mu is less than 7.7 hours, okay? Which makes our null hypothesis will be stated as mu greater than or equal to 7.7 hours in symbols. So the null hypothesis in words is going to be smokers do not need less sleep on average than the general population. And the research or alternative hypothesis in words is stated as smokers need less sleep on average than the general population. Okay, so this is in symbols. And this is in words. There we go. So that's step 1. Step 2 is set the criteria that's already set for us, right? Alpha is equal to 0.05. So the problem tells us what the criteria is, okay? And notice again how I pulled out all of the pertinent information, all the information that I need in order to calculate the z-test, or the z statistic. Mu is equal to 7.7, sigma is equal to 0.5, n is equal to 64, m is equal to 7.5, and alpha is equal to 0.05. So this brings us to step 3. So here's step 3, which is to calculate the test statistic, right? And again, we're using the z-test. And again, always do your denominator first so that you don't have to work with a fraction in the denominator. So let's calculate standard error first. And how do I know that I'm supposed to calculate standard error? Right here, because I have a sample size, right? So I have a sample, so I have to calculate standard error. Okay, so standard error, sigma m is equal to population standard deviation sigma divided by the square root of sample size n. So this is equal to 0.5 divided by the square root of 64, which is equal to 0.5 divided by 8, which is equal to 0.0625. So that's a really tiny standard error, okay? Our z statistic is equal to sample mean minus population mean divided by standard error. So 7.5 minus 7.7 divided by 0.0625 gives us negative 0.2 divided by 0.0625. So this is equal to negative 3.2. Okay. Now remember, we're looking for, right, mu is 7.7, and we're looking to the left, right? So 7.5, and we're looking for scores right? Less than. So we're going to look for the tail. This is a left tail, right? We're looking for the left side of the distribution and still in the tail, okay? So we're dealing with a negative number, but don't despair because remember, with a normal distribution, whatever happens on one side of the distribution is the exact same thing that happens on the other side, right? So we're going to be looking up the probability for a z of 3.2 or negative 3.2, but in this case it's going to be 3.2. So let me go ahead and pop over. 3.2 is right here, 3.2 in the tail, and this is a really tiny proportion, right? 0.0007, okay? 0.0007. There we go, there's the probability. Okay. This probability is much lower than alpha equal to 0.05. So our decision, step 4, is to reject the null hypothesis. And since we're rejecting the null hypothesis, we must calculate the effect size because there is an effect or a difference. So again, Cohen's d, right? D is equal to, remember, sample mean minus mu divided by sigma. So it's 7.5 minus 7.7 divided by 0.5. Now notice how I removed the negative sign. It would be negative 0.2 divided by 5. However, effect size is a magnitude, and so magnitudes can never be negative. And so when we're calculating an effect size, we just remove the negative sign. It's always going to be positive, okay? So Cohen's d is 0.4, a positive 0.4, and it's always positive, even though the calculations give you a negative, okay? So the conclusion, so now we can do the APA style conclusion. Reject the null. There is sufficient evidence to conclude that smokers need significantly less sleep. We need to provide the statistical evidence, and this is where we go ahead and place a comma, put z n equal to 64 is equal to negative 3.2, comma, p is equal to 0.0007, comma, d is equal to 0.4, which is a medium effect. Now we can say it in English. Smokers need less sleep on average than the general public. And there we go. Example number 3, done.